Imagine you are standing beside a river. You are thirsty. The water is right in front of you, but you have no bottle, no filter, no purification tablet, and no laboratory to test it. You scoop up a handful and look at it. It looks clear. It smells normal. There is nothing telling you that microscopic organisms could be hiding inside. Now imagine this is not a one-day problem. It is your entire life. For ancient humans, water was everywhere, and safe drinking water was not. That distinction could mean the difference between staying healthy and becoming dangerously dehydrated. And there was another problem. You could not see the danger. In 1676, Dutch scientist Antony van Leeuwenhoek became the first person to observe microorganisms through a microscope. Ancient humans had no idea that this invisible world existed. They could only observe what happened after drinking. A certain pool might repeatedly make people sick. A particular spring might remain reliable. A river might look clean but become dangerous after contamination upstream. Over thousands of years, your ancestors had to learn these differences without knowing the biology behind them. But surviving without modern water treatment did not mean ancient humans were somehow immune to dirty water. In fact, archaeological evidence shows that parasites and infectious diseases have accompanied humans for thousands of years. So how did you survive? The answer begins much earlier than the invention of water filters. It begins with knowing where water was, and that was harder than it sounds. In dry environments, water does not spread evenly across the landscape. A river valley can support life for miles. A seasonal pool can disappear within days. A spring can remain available even when surrounding land becomes dry. Your survival could depend on remembering exactly where one existed. Archaeological sites show that ancient human activity repeatedly clustered around reliable water sources. At sites across Africa, Asia, and Europe, water access shaped where humans camped, hunted, gathered food, and moved between territories. You did not need a map. You needed memory. You needed to recognize the valley where vegetation stayed green. You needed to notice animal tracks converging toward the same location. You needed to understand seasonal rainfall. And you needed to remember what happened the last time you drank from a particular source. This was environmental knowledge, built through repetition. But finding water was only the first problem. Because not every source carried the same risk. A flowing river, a groundwater spring, a rain-filled rock hollow, and a stagnant animal watering pool could all contain very different levels of contamination, and you had no way to measure any of it. You had to judge the landscape. Sometimes the landscape gave you clues. A spring emerging directly from the ground could provide relatively protected groundwater. Rainwater collected before extensive contact with contaminated soil could also be useful. Moving water could be less exposed to some forms of contamination than stagnant water, although flowing water was never automatically safe. That distinction matters, because the phrase "ancient humans drank dirty water" makes the past sound much simpler than it really was. Your ancestors were not choosing between bottled water and a muddy puddle. They were choosing between different environmental risks, and they had thousands of generations to learn those risks. But here's where it gets stranger. The ability to recognize a water source was only one part of the problem. The bigger question was whether humans could actually change the water before drinking it. One of the most important technologies in human history was already sitting beside you. Fire. By at least 790,000 years ago, evidence from Gesher Benat Yaakov in present-day Israel suggests that early humans were repeatedly using fire in controlled ways. But controlling fire did not automatically mean you were boiling your drinking water. That distinction matters. Heating water requires more than flames. You need a way to hold the water. Early humans did not have modern metal pots. They used whatever materials their environment and technology allowed. Wooden containers, animal skins, plant materials, later pottery. And there was another method: heated stones. You could place stones into a fire, heat them, and then transfer that heat into water held in a suitable container. The water could become extremely hot without the container sitting directly inside the flames. We know that hot stones were used in traditional water heating technologies much later in human history. But there is an important limitation. You cannot take evidence of ancient fire and automatically conclude that every ancient population routinely boiled drinking water. The archaeological record does not support such a simple story. Different human groups lived in different environments. They had different technologies. They lived thousands of years apart. Some had pottery, some did not. Some had reliable fuel. Others lived in places where fuel was scarce. And even when boiling was possible, it would have required time and energy. So the question becomes more interesting. If ancient humans could not always treat water with heat, what protected them from the invisible organisms inside it? The answer is uncomfortable. Sometimes, nothing did. Waterborne disease is ancient. Researchers have found evidence of parasitic infections in archaeological remains dating back thousands of years. One striking example comes from Otzi the Iceman, who lived around 5,300 years ago in the Alps. When researchers examined his preserved body, they found evidence of several health problems, including intestinal parasites. Otzi was not simply a frozen snapshot of a healthy prehistoric man. His body carried evidence of the diseases and environmental pressures people could experience long before modern medicine. And parasites were not unusual accidents of history. They were part of the environment. You could encounter them through food, through soil, through animals, and through contaminated water. A small community living near a water source could therefore face an invisible biological threat every day. Imagine drinking from the same source as animals. Rain washes waste into the surrounding ground. That contamination reaches a water source. You drink the water. You become sick. Now your body begins losing even more water. This is where the problem becomes dangerous. The original problem was thirst. The contaminated water creates illness. The illness creates dehydration. And dehydration increases your dependence on water. A person could become trapped in a biological loop where the thing needed to survive could also become the source of disease. But there was another layer. Ancient humans did not need microscopes to learn that certain places were dangerous. They could learn through experience. If a group repeatedly became sick after using one source, that source might eventually be avoided. If another spring remained dependable across generations, knowledge of that location could become part of the group's survival memory. This kind of knowledge does not require a scientific explanation. You do not need to know what a parasite is to know that a particular pool makes people sick. You only need to remember the pattern. And humans are exceptionally good at remembering patterns connected to survival. This may have been one of the most important defenses ancient humans had. Not immunity. Not perfect sanitation. Experience. But experience had a limit. You could avoid a stagnant pool. You could choose a spring. You could collect rainwater. You could heat water when your technology allowed it. And still, sometimes, you would get sick, because clear water can contain invisible pathogens. A mountain stream can look almost perfectly clean and still carry microorganisms. A natural spring can be safer than a contaminated pool, but natural does not mean sterile. The modern concept of drinking water safety depends on testing and treatment. Ancient humans had neither. They were operating without knowing the enemy existed. And yet they survived long enough to spread across almost every major environment on Earth. That means something important was happening. Humans were not simply surviving despite dangerous water. They were learning how to manage environmental uncertainty. And the next question is even more revealing. If bad water could cause disease, and ancient humans could not see the danger, why didn't waterborne disease wipe out human groups completely? That's where survival stops looking like luck. The answer is not that ancient humans had stronger stomachs. It is not that they were immune to parasites. And it is not that natural water was secretly safe. The answer is that risk was uneven. Not every water source was contaminated. Not every exposure caused illness. And not every illness was fatal. Your ancestors lived in environments where water quality changed from place to place and season to season. A spring could remain relatively reliable. A temporary pool could become contaminated quickly. A river could change after heavy rainfall. A water source used heavily by animals could carry different risks from one that emerged from protected groundwater. This meant survival depended partly on choosing between imperfect options. And that choice could become cultural knowledge. A group did not need to understand bacteria to remember that one location was better than another. They could pass information from one generation to the next. This is one reason human survival cannot be explained by biology alone. it was also a problem of memory. Consider what happens after rainfall. Water spreads across the landscape. It fills depressions. It moves through soil. It carries material from the surrounding environment. A water source that looked safe yesterday could become different tomorrow. Ancient humans therefore had to understand something that modern people rarely think about. Water was not a fixed object. It was part of a changing system. The same river could be different in the dry season, and after a major storm. The same pool could be useful when newly filled, and dangerous after sitting for weeks. The same spring could become critically important during drought. This made seasonal knowledge extremely valuable, and then humans began changing the problem itself. By roughly 10,000 years ago, some human communities were becoming increasingly sedentary. Agriculture expanded in several parts of the world. Permanent settlements became more common. People began living in larger groups. And now water was no longer just something a small mobile band needed to find. It had to support an entire settlement. That created a new problem. More people meant more waste. More animals meant more contamination. And more permanent occupation meant humans could remain close to the same water source for much longer. The water problem had changed. A small group moving across a landscape could leave a contaminated location behind. A permanent settlement could not. This pressure eventually contributed to increasingly sophisticated systems for storing, transporting, and managing water. Ancient civilizations built wells, cisterns, channels, reservoirs, and other water infrastructure. By the 3rd millennium BCE, large settlements in parts of the ancient Near East were already developing complex systems for managing water. Thousands of years later, civilizations such as Rome built enormous aqueduct networks. The Roman aqueduct system eventually stretched for hundreds of kilometers. But even these systems were not the same as modern drinking water treatment. Moving water is not the same as making water microbiologically safe. The modern transformation came much later. In the 19th century, scientists increasingly connected contaminated water with infectious disease. One of the most famous cases involved John Snow in London in 1854. A severe cholera outbreak struck the Soho district. Snow mapped cases and noticed that many were concentrated around a particular public water pump on Broad Street. His investigation helped establish a powerful idea. Water could act as a vehicle for disease transmission. The invisible danger that ancient humans had experienced for thousands of years was finally becoming scientifically visible. Later, advances in microbiology, sanitation, filtration, and disinfection transformed drinking water. By the 20th century, many cities had systems designed not simply to bring water into homes, but to make that water safer before people drank it. That is the world you live in now. You open a tap. You expect the water to be safe. You do not examine the river upstream. You do not watch animal tracks to locate a spring. You do not need to remember which pool made your ancestors sick last summer. A complex infrastructure performs those decisions for you, and that changes something fundamental about how you experience thirst. For ancient humans, thirst was connected directly to the landscape. For you, thirst is connected to a system hidden behind walls, pipes, treatment plants, reservoirs, laboratories, and regulations. You see the final few seconds. Water comes from the tap, but the history behind that water stretches back thousands of years, before filters, before microscopes, before sanitation systems, before anyone even knew microorganisms existed. Your ancestors stood beside the same basic problem. They were thirsty, the water was uncertain, and they had to drink anyway. The difference is that they learned to read the world around them because there was no other option. Today, you can drink without seeing the landscape that made your water safe. And perhaps that is the strangest part. The greatest sign of how far humans have come is not that you can find water anywhere. It is that you can finally stop thinking about whether the water will kill you.